Good morning, sir.
Very good morning. Have you revised what we had done on the previous class? Any of you? Say yes or no. No, also is fine. I need some sound from you. That's all.
Yes, sir.
Yeah, very good. Any other people want to reply? So let me share it. You see this? Yes or no?
Sir.
Very good. So yesterday we reviewed the definition of set and we introduced the notations, the description of set. Various descriptions are there. We shall use all of them. And this roster method, listing method, we shall not prefer. Sometimes it may be very lengthy. We cannot write it down. So we shall be happy if we are able to write it in the third set builder method or property method. So we are going to collect the elements which are sharing a common property. And then a few examples you have given, examples from mathematics and from the real life. And one example was related to your earlier course, calculus or differentiability. And then we considered family of sets or family of sets or collection of sets or set of sets. Various names are there, meaning we are collecting the sets. Set itself is collection of objects. Then we explained what is not a set. There is a separate topic. Since you are computer science students, there is one other topic, fuzzy mathematics. Fuzzy refers not well defined. Suppose if we say that evening during sunset we shall go to the canteen. If I mentioned that, there is no concreteness in that. If I say evening we shall have coffee, it may be 4:30 or it may be 5:30 or it may be 6 or it may be even 6:45. We don't have any concreteness. So if I give a time bound, you will not be able to decide it. What time is actually the evening? Maybe you can give a range. That kind of decisions, that kind of sets are fuzzy sets. We do not worry about them. In discrete mathematics, we are interested in the well-defined concrete sets. And we introduce two symbols. These symbols will be useful in describing a statement, in describing the property of a set. We shall use it soon. And also we explained few statements which can be assigned a true or false value. The truth value can be assigned. They can be returned using the quantifiers. Universal quantifier is used in the slides. Look at this one. When I give the statement 3a, you know that whether it is true or false. And I write another statement 3b. Now I call these statements are negation to each other, with the understanding that at a particular time, one of them is true, the other one is false. They cannot be simultaneously true, they cannot be simultaneously false. If 3a is false, 3b must be true. If 3b is false, 3a must be true. That kind of paired statements, we call it as negation. I give you one statement, you have to give me the negation. in terms of English. Look at the blue color statement on the screen. Every student in our class is punctual. You have to write the negation for this statement, which is written below. No, sir, this is incorrect. I have another statement. There is a student in our class who is not punctual. Mathematics comes later. Is it okay? Do not worry about practical possibilities. Like we were writing like 4 eyes, 3 eyes, all those things. Now here we are concentrating a statement and a truth value. A negation for that statement and a truth value for that. Anybody revised these things? Do you see the screen? Is it visible? Now from you, I need a statement involving this quantifier. There exists. Maybe one more example I'll give, then you may try that. I give another statement. Or simply today let me give you some statement. Say I call this as yes. Yes is statement. Okay. This statement is denoted as capital S. I have to write some English sentence. Can you give me some English sentence involving there is some or at least for all? Let me say there is, or in other words, let me say in our campus some buildings are white colored. This is one sentence. NITPY campus. Probably you have not visited. That's okay, imagine. So there is only one truth value. This can be true or this can be false. And when I say some buildings, this is actually serving as quantifier. I need another statement which is negation to this. This tilde symbol is used as negation. In our course, we shall use this. Can somebody say the negation of this statement? The negation definition is that if you have one statement, you will be having a truth value. Negation will have the different truth value. They cannot be simultaneously true. They cannot be simultaneously false. Can somebody say, first of all, you decide whether this is true or false. Even though you don't know it, you can find the negation. Can anybody try this? So if it is difficult, okay, let us try that first. In our campus, there are some buildings which are white in color. That's what the meaning of the sentence. What do you think? Somebody say yes or no first. Say something.
So you want us to negate the statement, sir?
Yes, I want this statement should be negated. Negate this statement.
In our
None of the
campus,
buildings
some
are white.
buildings are not white in color.
In our campus, some buildings are not white in color. Let me write it.
None of the buildings are white.
Okay, you people are suggesting many things. None of the buildings are white. none of the buildings in our campus. Maybe let me write down this in our campus up front. In our campus, none of the buildings are white. Is that what one person mentioned? And another student mentioned that in our campus, some buildings are not white color. Which one is appropriate? You see, yes is the statement. This is actually denoting negation, yes. Negation of the given statement. Negation with the meaning that which statement is having the next truth value. If the statement is true, negation is false. If the statement is false, the negation is true. What do you think? Two statements we are having. Which one? First, let me say 1 or 2. Which one you say is very appropriate? We are finding negation. Let me take second statement. In our campus, some buildings are not white colored. In that case, some other buildings may be white color. Are you understanding the thing? So the second statement is not negation. Are you following? In our campus, look at the second statement. In our campus, some buildings are not white colored. In that case, some other buildings may be white colored. Then the first statement will become the subset of the second statement. This implies that both will be having same truth value.
Sir,
Yes, tell me.
in our campus there exists a building which is not white color.
Okay. In our campus, second and the third statements are same. In our campus, there exists a building which is not white colored. Second and the third statements are same according to mathematics. Reason is that when I say that there is one good student in our class, it means there may be more also. If somebody asks me, I need good students, I need one student, I'll say that there is one good student in computer science class. According to mathematics, it means that there is at least one. There may be more students also. I'm not using the word exactly one. So in that case, this there exists a building and some buildings are having the same meaning. Second and the third are giving you the same meaning. This is our rough work. The first statement is actually the negation for the given blue color statement. I shall tell you why. But we have to write it properly. All these we tried, okay? We tried these possibilities. We want to write down the negation. According to me, the negation is the first one. In our campus, none of the buildings are white color. That negates the given statement. How do I write this? Before that, I want to write down this in terms of mathematics. This I am writing using symbols. There exists building in the set of buildings at NITPY such that B is white colored. Some buildings are there. That's what I referred as. There is at least one small B. B stands for building in the set of buildings at NITPY. Now I want to make this into wrong. I'll be writing that as, instead of there exists, I shall be writing, you give me any building in the buildings at NITPY. Building is not white colored. If we want to write down in terms of English in our campus, none of the buildings are white colored. That means all the buildings are not white colored. This, look at this English statement, the whatever I have written in blue color will create some confusion. All the buildings are not white color means some are white color, some are not white color. Again, the first statement will become true. And so I use quantifiers all the time. And so I am using this, so that the meaning is very clear without confusion. That's why we are introducing these notations. Are you following this? So when we use quantifiers, negation is easy. Layer by layer we can do it. This is outer layer. Within a bracket is conclusion is available, that is inner layer. Layer by layer you can negate it. Whenever there is occurring, you can write for all. Look at the, compare with the previous one. Look at the green color. For all S belongs to X, S is punctual. Small s is student. I gave a name for set of students. For all comes, you are writing there exists. S is punctual becomes S is not punctual. Observe the usage of quantifiers. When you use quantifiers, negation is easy. Is it okay? This all the buildings are white colored. That is actually giving me some confusion, right? All the buildings are not white, meaning there may be white, there may be non-white also. Instead of that, I write little more better statement. In our campus, given any building, that building is not white. This is more appropriate in conveying what I have in my mind. It is not white colored, of course. You see, we have written all of them are correct. Which of them are correct? The statement 1, which some student gave me in our campus, none of the buildings are white colored. That's correct. I am rewriting. Yes, all the buildings are not white colored. Then again I have confusion, so I am rewriting. Yes, in our campus, give me any building that is not white. One by one you can show. That's what I have written in green color here. In green color sentence. Look at compare only the green sentences. B is white colored, B is not white colored. There exists, B belongs to set of buildings. Given any, actually this, maybe instead of writing an ATP and all, I have to write somewhere. Let B is set of buildings. Sorry for this. You have to mention what is the underlying set we are using. Set of buildings at NITPY. NITPY campus. That's it. Here capital B I have used. In the earlier place I have used capital X. So let me write down the general form. Are you following what is a statement and what is a negation? How to do it mathematically using quantifiers? If you have any question, you can ask me. You have any questions? Observe the general form. I am writing there exists small x in capital X such that small x has property P. Or in other words, I am writing given any, instead of x, let me write some other letter. Let me write on this. X has, maybe we shall write things together. X does not have property P. Which property? The same property I have used. Property is being white color, being not white color. Have the property. This is our statement. If this is our statement, this is a negation of statement. One example, okay. Another example, I give a statement T, which is you give me any element from this underlying set, X has property P. This property P is being punctual. No, sir, there is one student in the set of students. X does not have that property. So this is actually the negation for the statement. We have done both of these. Now we are writing the general form. Actually, first one and the second one we have changed it into the. Maybe we can write it in that case itself. Sorry for that. I want to write down with the same order. So this is what we have used already. This is it. Our first example and our second example. That's it. Statement and negation, we have changed the quantifiers. Are you following these things? Someone speak.
Yes, sir.
You can try many sentences. There are various mathematical statements which need more than one quantifier also. Have you ever studied group theory? Identity element, inverse element kind of things? Say yes or no? I'll tell you one more thing. Okay. One example for usage of two quantifiers. First, let us do some rough work. I give you set of integers. I have one element from the set of integers. You give me any element. I'm having this already in hand. Some special, I'm not telling you, it's like a puzzle. I'm not telling you what is that number. I have one number, I call it as E. Now I ask you, give me any number, I will be having your number plus my number is your number only. Can you tell me what is my number? Are you following the question?
0.
0.
0. Okay, let me write down your answer. You have Z, then 0 belongs to Z. Now, instead of any number, okay, that also from Z. A plus 0 is A. Okay, you are right. I want to write it down. 0 comes first. Okay. This is our rough work. So let me say 1. There is one element in set of integers such that you give me any element from that set of integers. I have the property A plus that element is the same A. You have done the rough work here. Okay. Rough work meaning to understand these things are happening actually. The proofs and all we may look at in later units. So you are telling me that A is 0. Oh, sorry. E is 0. Some name I have given. Okay. Now another rough work. Another rough work. Suppose if I give 3, I need another number. If I add that another number, I should get your E. E is already 0. Use the same thing. What is this question mark? -8 plus second question mark. Okay. I need E. E is 0. The same E you can use here. What is the first question mark value?
-3.
-3. Here it is 8. Whatever number I give you. Suppose if I give you A, what number you will use in this place for getting E?
-A.
You see, here you are suggesting -3. Here you are suggesting 8. Here you are suggesting -A. Meaning, based on this number, you will choose the red color number. The statement is, given any element from the set of integers, there exists another element from the set of integers. What is the property? Our element and the new element is giving us E. Do you see that? Instead of A, I give you 3. You have to find out B based on what I have given you already. 2 examples for using 2 quantifiers in the same statement. 3 quantifiers also can be used. 4 quantifiers also can be used. It is based on the situation. Look at this for given any symbol, for all symbol is given up front. Their existing symbol comes after that. This order of occurrence matters to us. If you change the order, the meaning also will change. Look at B is depending on A. Whatever you are going to give me, based on that I will choose B. So B is depending on A. If you change it, that gives different meaning. Is it okay? Now, after understanding these quantifiers, you can go through these and you can try for examples also. Now we shall go back to the set theory again. So let me take some sets like A, B, or sets U refers universal set, which is having all the elements. Okay. Now we want to define what is the meaning of A complement. A complement is set of all elements from U with what property? A complement. Set of all elements from U with what property?
X does not belong to A.
X does not belong to A. Okay. I want to define A subset of B. What is the property? Definition I am asking you. A subset of B. What's the definition? A subset of B if, tell me that. I'm sure all of you know. Somebody speak it.
A intersection B is A.
That is a consequence. A intersection B is A intersection B is what do you say? A is smaller, so it must be
A.
A. This is consequence actually. You can say that these are equivalent condition. These are equivalent. This gives that and that gives this, all those things. I'm asking about the meaning of this. Definition. When do you say this is subset of that? Your class is subset of your department students. How do you say that? Set of students in second year computer science is subset of set of computer science students. How do you say that? Definition I'm asking. How will you check it? Say for example, yeah, let's
When all elements of a particular set belongs to another big set, superset.
Okay, use capital A and capital B here. You are right, almost. Be concise. All elements of.
When all elements of A are present in B,
Very good.
telling A is a subset of B.
So I want to write it down. So what I do is that all elements of A must be in B according to our capital A and capital B. So A is subset of B if all elements belonging to A. You give me any element X from the set A, we must have that must be in B also. You see, this is a property we expect. X belongs to B is a property. Look at, we are going to check one by one, not all at the same time. This is some rough work, leave that. A is subset of B if given any element X belonging to capital A, we have that X belonging to capital B. If this is happening, then I say that A is subset of B. You said in terms of English, I am writing in terms of the notations. I want to write down one more thing. Are you understanding this definition? Whatever you said, I have written. Shall I proceed? I want to write down what is A is not subset of B. How do I write it? When do you say that A is not subset of B? don't go for mathematics. Just imagine, then get some idea, then formulate it in English, then write it in mathematics. When do you say A is subset of B? A is not subset of B.
There exists an element in A such that it doesn't belong to set B.
Yeah, if there is one culprit who is not in B, that maybe more culprits also are okay. So you will be saying there is one element in A. What is the property? That element is not in B. One is enough. If there are more such elements, we will be happy. Are you understanding? This is why we need negations. Look at this and this are negation to each other. You compare this definition with our last slide yesterday. For all this, X belongs to B. For there exist some elements, X is not belonging to B. Read this box also. Okay. A is subset of B. One more thing. I am defining J union B. Is actually set of all elements from the universal set with the property that X in A, what is, say, complete this definition of A union B.
X belongs to A or X belongs to B?
R. X belongs to B. Okay. You are going to collect all the elements, okay, all with this property. Now, I give you one element belonging to A union B. X we have already used. So let me use some other letter. Okay. A. This belongs to A union B. I want to define if what happens. I say small element A is in this union. What is the definition? When you will say that this is correct? If definition is here already. Can you complete it?
If A exists in set A or in set B.
A belongs to A or A belongs to B. Somebody wants to say A is not in A union B. How do you define it? A is not in A union B.
It is not in A set A and set B.
And you are using and. Okay. Here also it is not there. You are having, observe, you are having yes or T kind of statements. When you take negation, that becomes negation yes and negation T. Is it okay? It's like, say, you are going to a mobile shop, you will be buying a mobile phone if it is having 4 GB RAM or 64 GB capacity storage. You need this or that. If both are okay, that also is fine. And you are not buying it. What may be the reason? Let me write down here. You need 4 GB RAM or you need 4 GB. Is it okay? 4 GB RAM. And the storage, you need 64 GB. Either this or that you need. Or we shall write one more thing. You need 4 GB RAM or 2.5 GB Not 2 gigahertz. What is that? Speed, processor speed. You need a mobile with any one of these property. You are visiting a mobile shop. If the shopkeeper shows that both are available in a mobile phone, will you buy it or not? We are using that kind of thing whenever we use the symbol OR. Inclusive OR. It has 3 possibilities. Only 4 GB RAM, you will buy it. Only 2.5 gigahertz speed in the mobile phone, you will buy it. If both are available, in that case also you will buy that. When you will avoid the mobile phone, that's the negation I am talking about. When you will be avoiding the mobile phone. Can somebody conclude this?
If neither of it is not there.
If both are not there, that means I will be writing that you will buy the mobile phone. You will not buy if it is 4 GB RAM also is not available. 2.5 gigahertz speed also if it is not available. If both are not available, you will not buy it. That's what is explained here in red color. This is a negation. This is the actual statement. That's what is happening here also. You want A belongs to A union B. The negation is A does not belong to A union B. Is it okay? The same thing can be extended to many sets also. A1, A2, A3. That family also. Let me quickly go through that also. Consider a family of sets where you are having A1, A2 till A10. Each A1, A2, A10 are sets. Capital letters I have used. Now, use and also consider union I equal to 1 to 10. All these elements. All the sets you are taking union. Among all the sets, you take intersection. Now I am saying a point. I am saying X belongs to this union. What does it mean? X belongs to this union. If can you use quantifiers? Can somebody try this? Instead of A union B, I am using union of 10 sets. The same thing I have written here. Here I have used this belongs to A union B. Instead of A union B, now I am using A1 union, A2 union till A10. Can you tell me that? When do you
X belongs to A1 or X belongs to A2 or X belongs to A3 and so on up to, or X belongs to A10.
Excellent. We shall write it little short. First, let me write down whatever you told me. X belongs to A1 or X belongs to A2 or X belongs to A3 or X belongs to A10. If any one of these is happening, then I say that yes, X belongs to the union. Instead of this, writing this, okay? Instead of that, let me write down if there exists one I among these 1 to 10. For this, let me write down little more clear, okay? I want to use quantifiers. So the same thing I am rewriting. X belongs to this union if any one of these is happening. If there exists one number or one set among all these with the property that X belongs to that AI. Whatever you told me in blue color, I am writing in green color. If there is, in terms of quantifiers, I am writing. Yeah. There is one set with a property that X belongs to that set. What do you mean by X does not belong to this union? If, can you say that? You have to take negation. X does not belong to union. What does it mean? It means X does not belong to A1. What is the next term? Can you tell me?
For all I belonging to 1 to 10, X does not belongs to AI.
Just for others, can you tell me in terms of English or in terms of the notation we used in blue color? X does not belong to the union of 10 sets. If I'm asking you to use something like this, whatever you have written in black or red, X does not belong to this 10 union set. If X does not belong to A1 and X does not belong to A2 and X does not belong to A3 till X does not belong to A10. Are you following it? So these are some basic properties. For intersection, you can try similar to this in terms of quantifiers. And are you following till this? We need this description, quantifiers, negations, everything we need. Are you understanding till this? I give you two sets which are subsets of X. We defined a subset already. I want a new set from these two. Can you do it? A union B and A intersection B are okay. Can you write any other set using these two? Let me introduce Cartesian product. If two sets are given, I am defining Cartesian product with a notation A cross B. It is actually all the elements from, where should I write? From X cross X, such that first element belongs to A and second element belongs to B. Have you ever seen these kind of things, Cartesian products? Say yes or no?
Yes, sir.
Yeah. So our idea is Cartesian product and studying relations between these two elements, X and Y. Reflexive, symmetric, transitive, all those things. And then we shall study a special relation, which will call us a function. It's time. Till this day is fine. We shall stop at this point. We shall meet in the next class. If you have any questions, you can ask me. Or any suggestions if you are slow or if you need homework. Homework soon I will give. Any questions so far? We stop at this point. Maybe you can type your roll number. All of you.
Sir,
Yes. Venkatesh, tell me.
No, sir, you told something I didn't hear.
Yeah, all of you type your roll number and you can leave the meeting.
Okay, sir.
Yeah, good. Just last 2 digits.
Thank you, sir.